In today's class, we are going to learn about the chapter Polynomials. So, in this chapter, first we'll discuss what are variables and constants. Say, if there is an equation given to us as 3x plus 2x square plus 5 is equals to 0. Then over here x is the variable and 3, 2, 5 are constants. Constant means they have a fixed value. Say another example, say ax square plus bx plus c is equals to 0. So again here, though a is unknown, here x is the variable and a, b, c are constants. Generally what happens is the alphabets after t are taken as the variables, like say 5t square, 5t cube plus 3t is equals to 0. So t is the variable and 5, 3 are the constants. Okay. Next thing is how to determine whether a given equation is a polynomial or not, or a given expression is a polynomial or not. Let's consider again some examples, but before that, our question is whether an expression is a polynomial or not. So whenever a variable is raised to the power whole number, then this gives a polynomial. And if the power of the variable is a fraction or a negative number, then it is not a polynomial. Okay. For example 1 again, say x plus 1 by x. So x plus 1 by x is basically x plus x to the power minus 1. Since the power to the variable is a negative number, so this is not a polynomial. Second, let's say root x plus 3. Root x plus 3 means x to the power half plus 3. So power half is again a fraction and not a whole number. Therefore, this is also not a polynomial. Number 3, say x plus a root under half. Okay, so x is our variable over there and half is the constant. What should have whole number as the power is the variable. So since x is the variable and its power is 1, that is a whole number, therefore this is a polynomial. The constant can have square root or anything. The constant doesn't matter. What matters is the variable should have a whole number in its power. Cube root of y minus 3y square. So cube root means y to the power 1 by 3 minus 3y square. So this is not a polynomial. Okay, so we understood how to detect whether a given expression is a polynomial or not. Next, what we are going to do is see the standard form of a polynomial. Standard form of a polynomial is basically a0 plus a1x square, so a1x plus a2x square plus a3x cube and so on till an x to the power n. This is the standard form of a polynomial. First point, if a1 is equals to a2 is equals to a3 is equals to dot 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 is equals to an, all of these are 0, then what we are left with is only a0. Then let's say this is p of x, then p of x is equals to a0 not equals to 0. So p of x is equals to a0 and this is called a constant polynomial. Whenever there is only a constant and no variable, means variable has the power 0. X to the power 0 is basically 1. So a0 and the variable has the power 0. It is the whole number. Therefore, this is also a polynomial and it is called a constant polynomial. Second point, if a0, a1, a2, dot dot dot, an, if all are 0, even a0 is also 0, then p of x is 0 and this is called a 0 polynomial. One more thing, the degree of a constant polynomial is 0. Degree is basically the maximum power to which a variable is raised. Over here, as there is no term only, therefore the degree of a 0 polynomial is not defined. Degree is basically whatever power, maximum power the variable is raised to is called the degree. Okay. Third, if a2, a3, a4, so on through an all are 0 and a1 is not equals to 0, then p of x becomes a0 plus a1x. So here the maximum power of the variable is 1. As the maximum power of the variable is 1, this is called a linear polynomial. the degree of linear polynomial is 1. Okay, remember that a1 should not be 0. If a1 is not 0, this will exist. If this exists, then it is a linear polynomial. Let's give some examples. Say 5x minus 3y plus 2, x, y, all of these are variable. 2z minus 5y plus 3. Okay, this polynomial has two different variables, but this is still a polynomial. All the variables have their power as whole number, that is 1 over here in this case. Therefore, this is also a polynomial. Number 4. If a3, a4, a5, so on till an all are 0 and a2 should not be equals to 0. If the coefficient of x square is not 0, then p of x becomes a0 plus a1x plus a2x square, and this will for sure exist. In this case, a1 is basically 5 and a0 is basically 0. Therefore, we have only 5x. a0 can be 0, cannot be 0. Like in this case, a0 is 2 and a1 is minus 3. Okay, so a0 plus a1x plus a2x square, and this is called a quadratic polynomial. Whenever the maximum power of the polynomial is 2, variable is 2, then the polynomial is called quadratic polynomial. The degree of quadratic polynomial is 2. Example: 3x square plus 2x plus 1, 5x square minus 7 by 2x, 3y square plus 5x minus 3z. Here the maximum power of the variable is 2, hence this is also a quadratic polynomial. This is a quadratic polynomial in 3 variables. This is a linear polynomial in 2 variables. Okay, depends upon the different variables that are there. We say this is a polynomial in 2 variables, linear polynomial in 2 variables. This is a linear polynomial in 1 variable. This is a linear polynomial in 1 variable. This is a quadratic polynomial in 3 different variables. And number 5, if a4, a5, a6 and so on till an is 0 and a3 is not equals to 0, then p of x is a0 plus a1x plus a2x square plus a3x cube. This is called a cubic polynomial. The degree of cubic polynomial is over here we have the maximum power of the variable raised as 3, so the degree of the cubic polynomial is 3. Example: 5x square y plus 3x plus 2y, 3x cube plus 5x square minus 2x plus 1. Okay, over here this is a cubic polynomial. Here power of y is 1, power of x is 1. In this one term only, what is happening is the power of x is 2 and the power of y is 1. So the total power over here becomes 3. So this is also a cubic polynomial. Understand, whenever you have variables in multiplication, you add the powers to find the degree of the polynomial. So this is a cubic polynomial in 2 variables. This is a cubic polynomial in 1 variable. Number 6. If a5, a6, a7 and so on till an all are 0 and say a4 is not equals to 0, then p of x becomes a0 plus a1x plus a2x square plus a3x cube plus a4x to the power 4, and this is called a biquadratic polynomial. Quadratic is power 2 or the degree 2, and biquadratic means the degree 4. The degree of a biquadratic polynomial is 4. Example, 5x square yz power 2 plus 1 total 4 plus 5x square plus 3xz plus 2. Then say 4x cube, 4x to the power 4 plus 3x cube minus 7x square plus 2. Maximum power of the variable is 4, hence this is a biquadratic polynomial. You have till biquadratic polynomial in your syllabus, and after that you will only be asked for the degree. You will not be asked what a polynomial is called. So remember, this stops till biquadratic polynomial. And the next topic that we are going to deal with is the coefficient. Say, okay, let's transfer this over here. So coefficients and terms. So a polynomial with one term is called a monomial. Example, 5x cube, or say 3, or say 5y, or say 7z. All these are monomial which has only one term. A polynomial with two terms is called a binomial. Example, 5x plus 2, 9x cube minus 7, 4z to the power 9 plus 3, 2x cube plus 7x square. All these are binomials because all of them have two terms, one term, two term, one term, two term, one term, two terms. And the last definition, a polynomial with three terms is called a trinomial. And after this we call all the polynomials as polynomial itself. Example, 5x square plus 3x plus 2, 27x to the power 4 plus 3x plus 5, 3x plus 5x square plus 3x cube. So these are polynomials that have three terms, or these are also called as trinomial. Next we are dealing with coefficients. So say for example, find the coefficient of x in number 1 5x cubed plus 3x plus 2 and number 2 5x squared plus 7. So in solution, the first part, the coefficient of x is basically 3. So the coefficient of x is 3. And for the second part, can we see any x term containing x? No, this is x squared. So as there is no x, this means the coefficient of x is 0. Whenever you are asked for the coefficient and if there is no term, then we say that the coefficient is 0, because if there was 0 as the coefficient of x, plus 0 into x would become 0 itself. That is why we do not write that term and the coefficient of x becomes 0. Okay. Next topic that we are going to deal with is zeros, or what we call as the root of a polynomial, and with the help of this we'll also understand what a factor is. So let's deal with this particular problem with some examples. So say, find the value of each of the following polynomials as indicated of the polynomials at the indicated value of variables. Number 1, p of x equals to 5x squared minus 3x plus 7 at x equals to 1. Number 2, q of y is equals to 3y cubed minus 4y plus root 11, sorry for this, plus root 11 at y equals to 2. Number 3, p of t is equals to 4t cubed plus 5 t cubed, 4t to the power 4 plus 5t cubed minus t square plus 6 at t is equals to a. So solution for number 1, p of x equals to 5x square minus 3x plus 7 at x equals to 1. So at x equals to 1 means we need to find p of 1. We'll replace x with 1. So everywhere what we'll do is we'll replace x with 1. So 5 into 1 square minus 3 into 1 plus 7. Wherever there is x, we'll just replace x with 1. So this becomes 5 into 1 square is 1, minus 3 into 1 is 3, plus 7. So 5 into 1, 5, 5 plus 7 is 12 minus 3. 12 minus 3 is 9. So p of x at x equals to 1 is 9. Okay, suppose if we would have gotten this as 0, then x equals to 1 would have been the root or the 0 of the polynomial. In the second part, q of y is equals to 3y cubed minus 4y plus root 11 at y is equals to 2. So we need to find basically q of 2. You can represent the polynomial with p of x, q of x, z of x, but make sure that you do not use the same alphabet in both of this. So q of 2 becomes 3 into, in place of y we are basically replacing with 2 cube minus 4 into 2 plus root 11 So this becomes 3 into 2 cube is 8 minus 4 to the 8 plus root 11. So this is 16 plus root 11. We cannot add what is inside the root to this. We'll leave this as our solution here. And the third part, we have to find P of t is equals to 4t to the power 4 plus 5t cube minus t square plus 6 at t is equals to a. So P of, we need to replace t with a. So P of a will become 4a to the power 4 plus 5a cube minus a square plus 6. This becomes our solution. Next question. Check whether -2 and 2 are zeros of the polynomial x plus 2. Okay, so in the solution, first what we'll do is we'll assume the polynomial, we'll give it a name, let p of x equals to x plus 2. You could have written q or say you could have used any other alphabet over here. That is not the issue, but make sure the variable is x, because in the equation we have x. So inside this bracket you need to take x itself. So let p of x equals to x plus 2 at x equals to -2. First we are putting -2. P of -2 is equals to, in place of x we will replace with -2 plus 2. This is 0. So after replacing a value, if you get the value as 0, this means that therefore x equals to -2 is the 0 of the polynomial. Whenever you get at a particular value, the value as 0, this means that this is the 0 of the polynomial x plus 2. So therefore x equals to -2 is the 0 of the polynomial p of x equals to x plus 2. Now we checked at -2, let's check at 2. At x equals to 2, p of 2 is equals to 2 plus 2, that is equals to 4. As the value we got is not 0, therefore x equals to 2 is not a 0 of the polynomial p of x equals to x plus 2. Next example, find a 0 of the polynomial p of x equals to 2x plus 1. Okay, for this type of question, whenever we need to find the 0 of a polynomial, what we do is let p of x is equals to 0, because the final answer should come 0, which means 2x plus 1 is equals to 0, which means 2x is equals to -1, and from here we get x equals to -half. So now if you replace -half in this equation, you'll get the value as 0. So this is how we find the 0 of a polynomial. Therefore x equals to -half is the 0 of p of x. Last example, verify whether 2 and 0 are zeros of the polynomial x square minus 2x. So solution, first of all, if there is no name given to the polynomial, we'll give it a name. So let p of x is equals to x square minus 2x. So as we can see, we can factorize this. Factorization basically means whatever there is common, we put everything in brackets. So if we take x common, we get x minus 2. Now we'll put then 1 by 1. So at x equals to 2, p of 2 is equals to, in place of x we are replacing 2, 2 minus 2. 2 minus 2 is 0, 0 into 2 is basically 0. Therefore, x equals to 2 is a 0 of p of x. At x equals to 0, we checked at 2, now we need to check at 0. At x equals to 0, p of 0 is equals to 0 into 0 minus 2. So 0 into anything becomes 0. Therefore, x equals to 0 is also a 0 of p of x. Therefore, both 2 and 0 are zeros of the polynomial x square minus 2x. With this, we come to the end of this lecture. Thank you.